Good morning, YouTube. Well, I got what we have there are the, come on Joe, you can remember this. Chair rail molding, blanks are cut, and half the crown molding blanks are cut. So I need a couple more yet, and then I'll be good. And I had to cut that stuff this morning because the boss decided she wants to go away for the weekend to see one of the boys, and she said, how about my oil and stuff, and how about washing my car and cleaning my car out? What's going on here? So everything else is on hold. I can get, my neighbor's going to take those strips that were left from the cutting the blanks. They're too small for, actually they're not too small for anything, but I already told him he could have them, so he can have them, and whatever else is laying there. I got my horses that far. No painting yet, or whatever you call that stuff, preservative, but I'll be getting there soon. So now I just need to take care of her car, and I had to clutter everything up in the garage here to get her car in because I wasn't really prepared for it. But that's what we're going to do. Wow, I really should move this thing over a little bit. Looks like it's almost off the ramps. I think I'll do that. Hey YouTube. You know, there's a number of ways to find level. You can use a water level, you could use a 4-foot level or a 2-foot level on a board or whatever. But I find that using this laser level that I have is easy, especially for one person. There's nothing to really hold except for the rod, and you just write down a couple numbers. So basically, here's what we got here. This is a Spectraphysics EL1 electronic level, and what another term for it is a rotating level, because it spins, and it casts out a 360-degree beam out from it. Now the beam is not visible. So this is not a laser that you would use to set ceiling tile, okay, or a perimeter in a building somewhere. Although you could use it to mark things by using the receiver. So it doesn't cast a line. But that's okay, because as far as I'm concerned, I wouldn't go anywhere or do any kind of earthwork or digging without this thing. I've had it since 1990. It's sat on the seat by me for years and years. I've never left anybody. I just hang on to it. Okay, this is my own personal one. I bought it, even though I was in business. I bought it and basically claimed it as my own. I really like it a lot, and I've used it thousands of times. And I've laid out jobs that are very big, maybe 60-acre jobs, just using this one little level, no transit at all at one time. So anyway, this is a pretty nice one. You can probably buy something similar to this now. A Spectraphysics 500 I think is about $1,200. So they've come down in price. What I like about this, and the new ones have it as well, is that it has an electronic level where what you do is you level it with the thumb adjustments to get the bullseye bubble basically in the middle. But if the level is off, you see the light flash in there and it'll stop spinning. That's what I like about this level. Okay, so now it's off level a little bit. Gotta adjust this. And once you adjust it and it's level, then it'll spin again. Okay, so there we are. It's spinning and it's level. Now this thing is actually fairly accurate. You can figure that in 800 feet, this could be off as much as 1 inch. But when you're doing earthwork, 1 inch in 800 feet is not a really big deal. Okay? And you can double check yourself or move it closer to you to eliminate or lessen the error. And there is a way to set this up with 2 stakes, which is a common practice for surveyors, to find out if it's working or not. So and whether it's throwing a level line, which sometime I can show you that, but that's not what this is for today. So basically what you got here is you got the head of this on a tripod. Comes in a nice box. It also has this receiver. Now this is not the original receiver that came from Spectraphysics. This is an off-brand because someone lost it or broke it or something, and that's all I know. That's what I can remember anyway. So I bought this off-brand, and if you ever do buy something like this, you want to buy yourself a square type of rod. I would not buy a fiberglass rod. I mean, I have fiberglass rods and you can use them, but this aluminum rod is nice because the way the base is made, it attaches good to it. A round rod, it doesn't attach too well to it. So anyway, this is the receiver, and what you do, it's picking up the thing here. What you do is you turn it on by pushing this lightning bolt. You turn it on, and you can adjust it to a fine or less than fine adjustment. You can see there's like a single line here, and then there's like a double line. This gives you a little bit of play. It's only an 1/8 of an inch play that you're getting, so it's not like it's a whole lot of variation. But if you're doing rough grading, like with a bulldozer, and somebody has one of these, you can be, you know, within a 1/2 inch or so without a problem, and usually that works out just fine. So anyway, you turn the level on. It attaches to this bracket in the back here with this knobby screw. Okay, takes AA batteries. This machine takes D batteries, 4D batteries. So anyway, you turn this on, and what you do then is you basically get yourself set up so that you're hitting that rotating laser. So right now where I have this, and I'm going to put this camera in the holder here so I can talk while I'm looking at this. I don't have to hold everything. Let me put it in such a way that you can see all of it. Yeah, I think that's good. Okay, so what's happening here is, well, what you use that for is to level things up. And as long as you can add and subtract, using this is pretty easy. So what you want to do is you can start anywhere. It doesn't matter where you start. You can call any number, any point you want, but you have to add and subtract from that point. So there's an arrow on here telling me that it needs to go down. So right there is the reading that it is from that rotating part of the laser to the concrete. So it's 3 foot or 3.20. Okay. Now, if you look closely at this rule, this is known as an engineer's scale. There's not 12 inches in a foot. There's 10, and they're not really inches. They're tenths. Okay, or hundredths. Okay. So let me see here. 4 and 1 would be 4.1. Okay, and then it's 4.11, 4.12, 4.13, 4.1 or 4.14, and then 4.15 at the bottom of this mark. So it's the top and bottoms of the mark that you're using to give you an idea of where you're at. So since you have something that can cast a level shadow, now what you or a level beam, now what you're getting is the ability to be able to find out what they are from one another. So I'll show you how I would do this. So you grab yourself a pencil and paper, or if you have a smartphone and that works, you can do that. So let's take a reading here. So we have a reading there that's 320, okay? So what we're going to do is we're going to write down 320, okay? And we can call that measurement there anything we want to, or that height of that concrete. So let's call it 500 for some reason, okay? Or let's determine the head of this, and let's call that 500. So the head of the instrument is at 500, okay, 0.00, and that thing is 320 below that head. So 320, put dollar signs on this. So the reading that we would get, if we call that 500, okay, where the level is, 320 below 500 is 496.80. So we're going to call that 496.80, and this is in feet, okay? The .80 is the equivalent to inches, and that would be like in this area. So obviously, if there's only 10 points to a foot, or 10, I'm going to call them inches, but they're really called tenths. If there's 10 inches in a foot, okay, that means that if you're reading 20, you have 80 left. So 496.80 would be the reading of that pier. So then what you do is you take this and you go to the next pier. And the best thing that you could do, before I get too far ahead here, is draw yourself a little picture. Okay, so that would be against the house. So we could write the house here, door here, and then we'll have another set, and then we have two down here yet. Okay, and this is the shape of the deck. Okay, so this one here then is 496.80. Okay, that's the elevation. Oh, there I go with dollar signs again. I guess you know I'm always thinking about money, right? 496.80. All right, so then we can go to any one we want to and get another reading. So let's see. Here's looking here. Let me go over to this. I may as well go to the second one. So this says it has to come up. So I look at this. All I'm doing is adjusting. I'm just loosening this bracket up and moving it up and down until it stops, or it still gives me a steady tone. So this is 3. That's a 3. So we're looking at a 2. So 3.2, and then 5 is here, 6, 7. So 3.27. Okay. So this is 3.27, and again that comes off of 500. Now, you don't have to use 500. You could use 10 if you want to make it a little bit easier. I'm used to using these kind of numbers because there's a variance on big projects. So 10 minus 7 is 3, 9 minus 2 is 7, 9 minus 3 is 6, 9 and 4. So this elevation of this one would be 496.73. Now, if you compare the two of them, 496.80 and 496.73, that means that that one over there is higher than this one, okay? This one is higher than this one by so many hundredths, all right? 10, 100, thousands, right? In the decimal point places. So 0.80 minus 0.73 gives you what? 7,000 or 7 hundredths. So that means that this is 7 hundredths higher or lower than this one. Okay, so the first one is at one place, the second one is at another. Now, it's real confusing for a carpenter to go from feet and inches to engineering units, but it's not for me because I've been doing it all my life. I use engineering units when I'm doing earthwork, and then when I get to building, I go ahead and I use feet and inches. So there is a conversion that's close, it's 1.2, but you don't need to worry about that right now. Just use these, and I'll show you what I do to make this a lot easier. So we're going to go to the third one then. So this one is 3.25, okay? So 3.25. So again, to take 500 minus 3.25, 10 minus 5 is 5, 9 minus 2 is 7, 9 minus 3 is 6, 9, and 4. So 496.75. So this one is 496.75, or 2/100ths higher than this. So think of sea level being 0, and as you come up, the higher you are, the bigger the number. So 496.75 is a bigger number than 496.73, and that's 2/100ths higher on that one than it is over here. Okay? Now 100th, just so you're wondering, is about the distance from here to here. That's all it is the thickness of that line. That's the 100th. Alright, so let's keep going. Okay, so that one is 3, and this is the 6 here, so 361, or 360, 1, 2. So 362. So 500 minus 362. 8, 3, 6, 9, 4. So that's this one, or no, this one over here. So the elevation of this is 496.38. Now where does that put that in relation to these other ones? Because the number's lower, it's down, okay? So this pier is lower than the rest of them that we've measured so far. So we're just going to keep going. Okay, so the reading then on this is 370, there's a 7 there, and then 1, 2, so 372. So 500 minus 3.72 would be 8, 2, 6, 9, 4. So this middle one here is 496.28. Okay? So this one is lower than this one. So this is the lowest one so far. And as we go over to, you'll see that they're going to get lower and lower. But this is how you use the level. And the good thing about this is this level is made for one person to use. Okay, one person. No one has to stay here by the level. You don't set this level on any particular point that you have. There's no need to. Although you can set it over a known point if you can measure from the point up, but it would be kind of impractical because it's just harder to do. You're better off setting it somewhere not on a point and then measuring to the point you know. For instance, let's say that the first one that we did over here was a benchmark, okay? And let's say we knew that that benchmark was any given number, whatever it is, 500, 300, 200, it doesn't matter, just some number, okay? We can take and get actual elevations on all the other things by adding or subtracting from that point. And in this case, it's going to be all subtracting because we are higher than everything we have here. And usually it is that way, okay? The only time you would be adding anything possibly is if you're going upward. So in other words, I could take the rod around and I could put it against something this way, like say I was measuring on, let's say I was measuring the bottom of a bridge and I had the laser sitting on the roadway below. I could extend the rod and measure the bottom of the bridge to see what its elevations are by adding the reading to the elevation of the instrument. But you have to find the elevation of the instrument. And I'm getting way over what I wanted to show you here, because now we're getting into surveying and you really don't need to know that at the moment. But anyway, this is how I use this. So I'm just going to keep going because this is going to help me to cut my 4x4s. Okay, so then this reading here is 3 and 7 would come before 8. It's right before 8. So it would be 378. Okay, so 378. So 500 minus 3.78. And I write everything down, believe it or not. It doesn't matter how simple the math is. I write it down because I can always go back, look at these numbers and say, oh, I made a mistake here. 10 minus 8 is 2, 9 minus 7 is 2, 9 minus 3 is 6, then we have a 9, then we have a 4. Okay, so 496, 496.22. I don't know whether you know this or not, but when surveyors do their work, everything that they do is recorded. If they have a data collector, it's recorded in the data collector. The old-fashioned way, when I used to do it, when I learned how to do most of the surveying I learned in the military, I was in for, let's see, most of the surveying I learned was from on the job site. So actually I learned from inspectors and I learned from my dad, and then I finally went to college for surveying as well as other things. But anyway, back to this. So 500 minus the reading that we have, which is 378, okay, 378, gives us 49622. So we have 2 more points to do and then we're going to be done. You want to make sure you're down on the concrete. Now besides what's happening in here, there's also a screen on the back, so I can hold this facing the gun or facing the level, and I can see if it has to go up or down from the back. What happens here is there's an arrow that points up or down, and when there's a straight line, that means you're on grade or you're where you want to be. It's where the beeper sounds continuously rather than beeping. Okay, so the measurement we have here is 478. Okay, so 478. So 500, 4.78. And guys, I've taught myself to not try to second guess this. I have taught myself to not do the math while or not think the math. Write it down. If you write it down, you always have something to go back and look at, and you can say, okay, here's where I made my mistake. If you don't write it down, you have no way of finding out where that mistake is. Usually I have a really nice field book that I work with, but I'm just showing you how I actually, would do this stuff. It's not that hard, it's just, this is how I do it. So 10 minus 8 is 2, 9 minus 7 is 2, and then 9 minus 4 is 5, and then 9 and 4. So 495.22, where was that? Let me check that. See, this is another good thing. You can check yourself when you forget what you've done. So I come back here, so that's the first one. Okay, so 495.22 is where that is. 495.22. Don't get scared with all these numbers, you guys who are not good with numbers. Don't let them bother you. Just write them down, okay? Know what you need to know. You could actually be writing down, the 327, the 362, and then do all your math later. That you could do that. I'm just doing it now to show you how I would do it. So now I got to go and check this first one over here. 5.18, or no, 5.987, 5.17, 5.17. So 500 again minus 5.17. Okay, so again, 10 minus 7 is 3, 9 minus 1 is 8, 9 minus 5 is 4, 9 and 4. So 494.83. 494.83. Now, I went through this pretty quick and I'm not checking myself at all. So when I go to do this, I'll check my math to make sure I'm right. That's why I have them written down, okay? And a lot of times I'll just sit down and use a calculator, as simple as this may seem, because it's better to check yourself. If you use your head to come up with numbers, and then you use a calculator to come up with numbers, there are a lot of times when we tend to say something is something and it's really not something. In other words, you could say, 9 times 5 is 45, or you could say 9 times 5 is 40, and it's not 40, but you're thinking it's 40, and you write down 40, and then you're wrong. So these are mistakes that you want to clarify yourself on, and this is what surveying is about. Surveying is about taking numbers and juggling them to the point that you're positive that that's what the number is. You average them in different things, and my son's a surveyor, and I used to tease him about it. All you do is beat the crap out of your numbers and finally come up with another number. And is that number necessarily right? No, it's not, because it depends on how close you're measuring. It's kind of a joke amongst surveyors. But anyway, now these are the numbers of the piers that I have, the elevation of all the piers. So I can go ahead and I can figure out then what I have to do in relation to the top of the deck. Now I'm just going to set this paper here for a second, and I'm going to walk over here, and now here's what I have to decide. Where do I want the top deck surface? I don't necessarily want the deck surface up right against the patio door, because I might get snow or rain in there from splashing. Although the way I am here, it's going to happen no matter what. So here's the thing. What I want to do here is I want to have the top of the deck board real close to the bottom of this J channel here, or the bottom of the corner post on the siding. So what I'm going to do is I'm going to adjust this till I have that. So what you can do with this, let me just lower this down. Okay, so I know basically somewhere in there is where I'm going to hit this. And I know that that's good. So the top of my deck then is 256. 66. 2.66. 2.66. So what I'll do then is again take 500 and subtract 2.66 from that. Okay, so 10 minus 6 is 4, 9 minus 6 is 3, 9 minus 2 is 7, 9, and 4. So 49734. Okay, this is top of deck. Okay, that's the top of the deck. Now, if I want to have something that I can relate to, what I could do here, because I have once I move the laser level, I have nothing to really relate to again. I could use, you know, maybe the post, but I'd be better off putting something on somewhere. So what I can do is, since this thing isn't going anywhere, right here, okay, so I'm going to put an X on this stone, and then my reading here, oh, wouldn't you know it, it's down where it's rubbed off. Okay, so this is this would be 1 point, yeah, 1.95, 1.95, 1.95 is 1, 2, 3, 4, 5, 1.95. So I can write that benchmark over here. Again, we go 500 because that's the height of the instrument, okay? HI, or it depends if we're in the military, IH or HI, instrument height or height of the instrument. It's HI usually. So 500 minus 195, did I say 195? 500 minus 1.95. Yeah, 1.95. So that gives me 5, that gives me 0, that gives me 8, 9, and 4. So 498.05 is the height of the benchmark. Okay? And I'm also going to write down over here 500 is the height of the instrument, HI. Okay? So that gives me all the information that I need. And you should put your decimal points in there, 0, 0 equals. And that gives me all the information I need to figure out where I stand with this deck. Okay guys, so I had said that I would use this engineer's scale, which has basically 10 inches per foot, okay? And here's the thing, this is the tool that I use to transfer the numbers from the engineer's scale into carpenter's numbers, which would be feet and inches. And here's how I do that. It's very simple. Let's say that first pier, let's say 496.80 and 496.73. So 73 and let's see, that would be 7, right? Yeah, 7. So there's 0.07 hundredths difference between this pier and that pier. All I do is take the rule, 0 starts here, 7, right? 1, 2, 3, 4, 5, 6, 7. Turn the 7 over, and that gives me 7/8 of an inch. Or no, 3/4 of an inch. So that means that the difference between these two is 3/4 of an inch. This one's 3/4 of an inch higher. Yeah, this one's 3/4 of an inch higher than that one. Okay? That's what I need to know, that 3/4 of an inch. Once I know that, and the differences between all of them, by using this conversion, now you might say, well, it's just a foot rule. It's not just a foot rule. You notice there's 12 inches per foot, 10 inches per foot. This is known as an engineer's rule, okay? So it's a carpenter rule on one side, an engineer's rule, which is, I don't know if you can see that, tenths and hundredths on the other side. So tenths and hundredths, and then, what's that say, inches, yeah. So it's the closest 16th of an inch you can measure with this thing. So that's how I convert those numbers then. Now you might say, why not just get a rod that has the feet and inches on? Well, you can do that, but if you're a professional builder and you're a professional excavator moving into the building trades, which is what I did every day, we always had excavating going on while we were building. So I had to be able to talk to the engineers in terms of tenths and hundredths, and then I had to be able to talk to the carpenters in terms of sixteenths and eighths, okay, or inches. So that's what you need to be able to do. And this is what I used to do it. There's no math. I don't use math. I try not to use any math because I make mistakes if I use math. This way here I can look at it and I can go from there. So for instance, this is, like I say, 10 inches per foot. If you think about it, 0.5 then, 5 would be 6 inches. And if you turn over, there it is, 6 inches. So, you know, if it's 5.60, so this is 0.6 right at that line. So 5.60, you just look across there and it's equivalent to 7 and, let's see, 7 and an eighth, 7 and 3/16. So this is how I do this. It's not hard to do, but as long as you have this and the rod and the laser, there's nothing from a blueprint that I can't set in place. Now, not locating it. Locating side to side is a different animal. But there's nothing that I can't get the elevation of with these three things. The rod, the level, and this. Now, here's something else I'll show you real quick. I've been carrying this thing with me for years. This used to be in my back pocket every day of my life. This is what's known as a hand level. Now, this is a really good one. This one is made in France. Or no, what am I looking at here? Oh, Defiance. Defiance, New York. Okay, I was reading the wrong thing there. So anyway, this thing is made in New York, and what you do is when you look through it, there's a line across and you can see a bubble. So when I look through this thing, I take the line and I put it in the center of the bubble, and whatever the line sees out there in space is where level is. So in other words, just to give you an example, if I set this rod, let me open it up. Let's say I set this rod here, okay? I set the rod there, and I come over here, and I want to know, like, the difference between that and this, for instance. I can put this rule down here and take this. There's a point here on the side that shows me where I'm at. So I can look at this, and let's say 4 feet. I'm looking at 4 feet over there. Okay, so I got to find 4 feet. The bubble is inside here is going up or down depending upon what I'm doing. So right there's the center of the bubble, and I'm reading 4 feet. So that tells me I'm at 2'10" over here, or I'm at 2.80 roughly. So I look across there at 280, and I'm seeing the 4 foot mark. And what I can do is I can say, okay, so 4 foot, I'm reading 280 here, so this is 280 hundredths, or 2.2 feet and 80 hundredths lower than what the 4 foot mark is. It doesn't mean anything with this deck. I'm just telling you that that's how you can do this. This thing here is good up to the width, I don't know, I'd say the width of a 2-lane highway. I've used this many times in the center line of a road to get readings off of a grade stake or a string line so that I could you know, tell the operator whether he was high or low in his excavating work. I have another one here too. This is a newer one. I don't even know what brand this is. This may be a Burger, but you would use one of these nuts here, these brass nuts, as the point where you would measure from. And when you look through it, you can, I don't know if you can see that, but there's a bubble here. Can you see that bubble going back and forth? Let me see if you can see that. You see that bubble going back and forth there? When I look through this, I can make that bubble by tilting this real slowly. I tilt it until the bubble's in the center of the line, and then I know I'm looking level. And this thing is good, I'd say, well, I can probably be within an inch or so at about 50 feet. Okay, not much better than that, but that's really good though when you're doing rough grading. You can do quick. You can carry a foot rule with you, and I guess I shouldn't even go into all this, but anyway, this is a level that does the same thing that does. So if you were to take this rod, now you'd have to have two people with you. If you took the rod, like let's say I start over here, I open my foot rule up, and normally you go off of 5 foot because 5 foot's a good height to look through. So let's say I'm looking at 5 foot here. Am I at 5 foot? Yeah, there's 5 foot. So I put the brass button on the 5 foot mark, and then I look across here, and when I look across I can tell what the reading is there. Okay, I could read what the rod is doing. So over here the rod, now you got to realize that the 5 feet here is not the 500 on the electronic level. All I'm saying to you is that, like from here, when I read this, I'm looking at 480 over there, and it's pretty accurate. I mean, at this distance, I'm only 5 feet away from that thing. So at this distance here, I can definitely see, you know, get within say 200ths or so if I really watch what I'm doing with this. So this is just another way of doing things. So you could actually, instead of spending $2,000, if all you're doing is something small like this, buy yourself one of these. Have your wife hold the grade pole, and you don't even need to buy a grade pole. You can just take the pole and have her put a mark on it wherever you tell her. So in other words, let's say that I sit on a point, and you want to start with a known point, so you got to stay at one point. So if I hold this, if I stay right here and like say I throw a rock down, set my foot rule on a rock, hold this at 5 foot on that rock, and I look across, without having any numbers on here, I can say to her, put a mark here, okay, because that's what I'm looking at. When I look through here, I can tell her up or down with her finger. In other words, what she would do is go like this, and I would say up or down, and she would use her finger. I would be the center of her finger, and she just puts a pencil line there. Or anybody, it doesn't have to be your wife, it could be anybody, but I'm just saying, you're looking through here, and that's what you're seeing. What I'm showing you is old school, but it's old school that led to the new school, okay? If you can do this, you can certainly use the new stuff. And I do. I mean, I can use a total station to do the same thing, which is the latest technology that they have, or GPS. You know, if I have GPS, I can use that to locate and to get the elevation of stuff. I actually like doing this. I like doing it this way. I have a lot of fun doing it this way. I have it on paper. You can see my mistakes. I can see my mistakes. It's very easy to work with. So that's just, you know, a little bit on how you use the laser level and how you find out where you are in relation to one another. So real quickly then, all I'm going to do here is find the difference between each one of these, okay, in relation to the height of the deck. So the top of the deck is 497.34, right? So I got a 2-inch board or a 1-inch board. I'm not even sure which one I want to use. Let's say I use a 2-inch board, so you come down 2 inches, plus I would come down, oh, I don't know, 6 inches for the 2x6. So that's a total of 8 inches. So if you look at your rule here, at 8 inches, now I'm on the 12 inches per foot side. If I look at 8 inches and I roll over, I'm 0.66. So what I can do is I can use those numbers and juggle them a little bit to be able to come up with the actual feet-inch difference between one pier and the other. And that means I can cut my posts. That's what you do. It's that simple. Now I know I did a lot of talking here, but anyway, have a good one, guys. Bye. Hey guys, I just realized that you couldn't see this notebook out there, so I'm in the house, and let me just see if I can't show this to you real quick here. So basically what I did was I drew circles for the deck post. These are the 3 against the house, then there were 3 more, then there were 2 more, and I just wrote those numbers down, and my math is all up here, 500 minus whatever, okay, and at the bottom I wrote down here the height of the instrument, and then I wrote down the height of the fire pit, and then I wrote down the top of the deck elevation. So all of these elevations that I have written down here, like this would be the first 2, then there's 3 more, then 3 more piers by the house. Once I have this all figured out, I'll be able to tell what distance and stuff that I need to cut my 4x4s at. In other words, from the bottom of the 4x4 if I'm going to notch them or whatever. So I wouldn't have been able to see that. You couldn't see this anyway in the screen. It's so small. I thought I'd just show you this anyway, just so you knew what I was doing. I can barely see it anyway in the screen. Thanks. For those of you who have been watching for the hydroponics, I know I haven't been really doing a good job with that, but I just want to show you what we've got here. Here's my hand as a comparison to the size of these lettuce leaves and stuff. So my wife has cut, or pruned, or whatever you want to call it, harvested, and you can see the cuttings. She has harvested lettuce from this at least 15 times since when I first put the video up showing this. I think it was about a month ago or so. So we eat salad every Monday, Wednesday, and Friday, believe it or not. And this is where she gets it. Now, not always. Sometimes we have to buy extra. But once I get the greenhouse stuff growing in there again, then we'll have even more. So it's actually pretty nice. I mean, if you can, you know, just as a comparison, well, even to the milk jug, you can see the size of those leaves. Thanks, guys.